Hi everyone and welcome to this webinar. I can tell from the amount of people and audience we have in the session today that this is an interesting topic, and we think so here at CluedIn as well. I'm joined by Roman, who's part of our data engineering team, and my name is Tim. I'm also part of the CluedIn team. Today's topic will be about Azure Databricks and how to bridge this with CluedIn to make the perfect synergy and match between the business and the IT. So we once again just echo that happy to have you all on board here, and Roman and I are ready to give a really good show for everyone involved. So let's dive in and see what we're going to learn today. I think it's always good to start off with where we have come from and where we are. And that means we're going to take a look at the current situation that a lot of customers are in, a lot of companies with their data stack, and the kind of challenges that we're having. Then we're going to dive into how CluedIn can enable your existing Azure Databricks and Azure ecosystems, and then dive a little bit more into the CluedIn solution. Now, I'm sure that many of you on the call are either existing Azure Databricks customers or are looking at building up your technology stack today. So our job here is to see how these tools, CluedIn and Azure Databricks, can really complement each other and fill different parts of the overall data lifecycle and supply chain. We're going to end up by summarizing on how the business outcomes and benefits of having these two technologies work together. And this is really about how we're bridging the business part of data with the IT part of the data stack as well. And then we're going to end up with how you can start to get started with your Azure Databricks and CluedIn solutions, and how to engage with the CluedIn team to talk a little bit more about how we can help solve some of your challenges in the Azure ecosystem today. So let's dive in and start to talk about some of the current challenges and situations we are in the data space today. Well, if we look at a lot of data initiatives that are running across not only our own customers, but a lot of companies that we're talking to, data projects are inherently very engineering and IT driven. And involving the business users in the kind of supply chain of data is obviously something that's quite hard to do. If we take a look at the kind of data initiatives that we do run as businesses, whether that's implementing a data lake, whether that's implementing reporting and data warehousing, whether it's implementing data science, even from these names, you can start to gather that these are very IT heavy, IT driven initiatives. So we've got to ask ourselves, at what point do we start to involve the business in this data technology stack as well? I think it goes without saying that low data quality still plagues a lot of companies, and that's despite the actual technology investments that are made. Now, of course, with full empathy, we know that we need to take these types of challenges in some type of order. So where we see most companies today is they've established some of their data technology stack, whether that is the lake or the warehouse. What they're really looking at now is cracking this. How do we deliver high quality, mastered, ready for insight data to the downstream consumers and the rest of my business? If we look at that situation and then go into some of the challenges with this, I mean, there is growing pressure on IT and engineering to keep up with all the kind of demands from across the business to use data and become data-driven businesses. So really that pressure is growing for engineering to be able to provide that reliable and robust data quality pipeline. And thanks to technologies like Azure Databricks, we can now start to solve some of the challenges around scale, around the amount of data, and the time it takes to actually deliver that data to the business. But it is still hard to be able to make sure we're delivering the data that is ready for use. And this is really where CluedIn can help and complement that existing technology stack. The other piece is that, and I think that Roman and I can say this from our experience, both being in many, many years of software engineering and spend a lot of time in the IT teams, it's become really obvious that there are many parts of data quality that should not, cannot, and will not be fixed via an engineering and IT approach. There is the need, as you'll see in a lot of these data quality challenges, to start to involve the business. But that's the complexity. And what we're here to show you on this webinar is how we can help with providing a solution for that. So how can CluedIn enable your either existing or upcoming implementation of Databricks and the rest of your Azure ecosystem as well? Well, at a very high level, CluedIn is a solution that adds layers of DQ, data quality, master data, metadata management, and semantic modeling to your already existing Azure ecosystem. What does this mean? CluedIn is here to be able to help add a layer of technology to enable you to deliver high quality data that's ready for insight to your business. And these are just some of the pillars of data management that need to be put in place to be able to see this solution through. Now, the difference, and the big difference here, is that all the above layers that I'm mentioning here are business driven, business led, and business operated. And as we just alluded to before, a lot of these data initiatives are typically IT and engineering driven, led, and operated. So it'll be interesting to see how we can bridge these two so we can have that really great synergy between teams. And each team is doing what they should be doing and can do and will do in the overall data supply chain. So just a little bit of information on CluedIn itself. CluedIn is a recommended master data management system for the Azure ecosystem. In fact, not only is it a recommended master data management platform, it is also the recommended migration from Microsoft's own MDM system. Some of you might be aware of that. That's called Master Data Services. With native integration to over 27 Azure integrations and services, really becomes the natural choice for implementing these types of data quality, mastering, and data governance solutions in the Azure cloud. We're also in the Gartner perspective, we are a cool vendor in 2020 for our data management solution, and we were an honorable mention in the MDM Magic Quadrant this year to how to solve master data management type of initiatives for modern types of approaches and modern data stacks. And this is the typical ecosystem and architecture which CluedIn plays in well. Now, of course, there are many pillars here, and CluedIn is definitely part of a bigger overall stack, solving some of those data quality and mastering pieces. But very much it's about leaning onto other ecosystems and services that are in the Azure stack as well. In this case, we're going to focus on Azure Databricks up the top today and how we can have CluedIn and Azure Databricks work really well together to bridge the business and IT. So really, before we dive into the demonstration and see how these two teams can come together, CluedIn is really about how we can add the human factor to your data pipelines. Now, whether you're using Spark or Azure Databricks or something like Azure Synapse, as we've alluded to, that's really about how we can build repeatable, automated engineering pipelines. But along the way, we'll show you some examples of how we really need to surface some types of problems to the business and have them make decisions. However, we still want to keep that automation, that quick time to value. You'll see how we can do this soon with CluedIn. Really, it's about filling that void. I mean, we know that we need to involve the business in these decisions. It's about how we can still keep the scalability, reliability of Azure Databricks, but really bring the business in to help solve with some of those data quality pieces as well. Now, just like you probably booted up your Azure Databricks instance, we are just as easy to get as well and get started with. CluedIn can be installed directly from the Azure Marketplace. Just type in Master Data Management from your Azure portal, and in 15 minutes, you'll have a CluedIn instance up and running. We have a modern type of way to interact with the interface, abilities to easily bring data in, to semantically model it and align the way that we refer to our data. And we have all the pillars of data governance and data lineage to make sure that we have full trace and audit as we make changes to the data, but as we send it out to the downstream systems, such as reporting, data warehouse, and data science teams as well. CluedIn has intuitive data stewarding tools to make suggestions and discover what the actual data quality problems are, and then make suggestions on what the fix is as well. So you can even right now start to get a hint of how CluedIn can help with the data quality pipelines. And of course, CluedIn is a smart system, so all the decisions that are made by business users are logged into what we call business rules, so we can use them throughout the business for other reasons, such as our data engineering pipelines. So with that in play, let's set the scene. I've got Roman joining us here from our data engineering team, and Roman spends most of his time in Azure Databricks approaching these data quality and integration problems from a code-only perspective. In this particular scenario, I'm going to play the role of a business analyst, so I'm much more aligned with the business. And to be honest, I'm also responsible for the operational quality and health of the data as well. So we both have a generic interest in making sure that our jobs are done well, but that we're focusing on the parts that we're responsible for as well. So if possible, I'd love Roman to stay in just the engineering tools, and I'd love a tool to be able to help me make some of these decisions on data quality at a business level. Now, the actual scenario that we're working with today, and this is probably very typical. In fact, this was inspired by a couple of the customers that we're working with. We get roughly 1 gigabyte of data sent to us on a daily basis. Now, this is public data, and the data that we're using today is available from data.gov. So we're actually working with the same data that you also can download and work with. And within this data, we've got some pretty typical metadata, such as the doctors themselves, what city they work in, what university they went to, which hospital they're working at, and the address information of that hospital. We've also got things like the specialty that that doctor specializes in, whether it's psychiatry or surgery. And the problem is that with this coming in on a daily basis, Roman and his team just cannot keep up with preparing this data. Of course, Azure Databricks can easily take the amount of data. That's not a problem. It's just the amount of manual work that Roman has to fix the data quality issues is just growing and growing. And this is not getting better anytime soon. And I don't really have the solution of just adding more data engineers to this team. To add to the complexity, the data we're working with has a combination of structured data and unstructured content. So we've got things like unstructured addresses coming in that really don't adhere to any core formats or international standards, but we need to fix these types of issues because this is operational data that we're working with. And before I hand over to Roman, I just wanted to give you kind of an example of the data set that we're working with. And that one of the first challenges we're going to have as I hand this data over to Roman is actually to find these types of problems in the data. Just by scanning our eyes over a sample of the data set, we can already see that there's some denormalization problems in the data itself, where essentially, I guess you could say that psychiatry on the 4th row and psychiatry on the 5th row, this just example in the first red loop, well, they are actually semantically the same value. They've just been entered incorrectly. Now, this problem might be solved easily in source systems, right? So this might be by putting in drop downs into source systems to make sure this problem can't happen. But when it comes to things like addresses, that's not always possible. And this problem is accentuated more as you bring together data from across different systems. So this is the problem that we're dealing with. And now I'll hand over to Roman just to introduce himself, but also to start to talk about what types of approaches he would take to start solving this problem just with Azure Databricks. So over to you, Roman.
Thank you, Tim. So usually we use Jupyter notebooks and write code in Python. And here on my screen, you can actually see what I loaded the file, what you had in Excel. And it has about 40, it has 40 of columns and 2 million of rows. And on my daily basis, I need to write code that fixes the issues with the data, like fixing the formats of dates, addresses, or replaces the values that were misspelled. And it's a very time-consuming operation.
Perfect. So Roman, if you were to estimate on a daily basis, how much time do you think I would have to allot for you to go off and your team to fix this, just from an Azure Databricks perspective? And of course, this is not, this could be Spark, this could also be Azure Synapse, but just from a code-only IT perspective, how long do you think it would take for you to fix all the problems in this data?
Sure, I believe you would fix us 5 days in a week, because you can actually free one of the development resources who is working on this task on a daily basis.
Makes sense. So basically, not that this is very nice for you, Roman, but this is now your full-time job. And I can see that happening in that, you know, on a daily basis, if we were getting a whole gigabyte, 2.3 million records of changes and additions, that, yeah, you're going to be buried in this for a while. So I'm here to help, Roman. And the good thing is I don't need too much from your team. So what I'm going to do is I'm going to take back the screen, Roman, and I'm going to start to fix the data at a business level. And all I'm going to do is I'm going to ask you, I've just pinged you 2 lines of code in your Slack. Can you just put those after you've loaded the data? And once I've fixed the data quality issues from a business perspective, let's dive back to the code and just talk a little bit about what we've done. And then after that, I'll get you to run your Databricks job again, okay? But I'll take over from here.
Thank you, Kim. I just got the code.
Excellent. Good. So now we're going to log into CluedIn. So we've got a brand new instance of CluedIn that we've spun up directly from the marketplace. This is run in Microsoft Azure. And the good thing is CluedIn runs in my tenant, right? So all the data that I'm uploading, this is in my Azure tenant. So from a data privacy perspective, from a data sovereignty perspective, I feel pretty comfortable that the data's in a location and an environment that's owned by me. This is one of the important differentiators with CluedIn. So what I've done is that big file that that Roman was working with, I've loaded that into CluedIn, and I've loaded it directly into CluedIn's cleaning application. So this is a tool that's focused towards a role called a data steward. Now, these data steward roles, they're not necessarily engineers. They're people that are comfortable with working with Excel, tabular data. You could also say a business analyst or a data analyst, but what we're wanting is someone that knows a little bit more about the data from a business perspective, and this is what we call a data steward. Now, this is not a typical role that you would involve in Azure Databricks or a lake or a warehouse, and this is where MDM and CluedIn becomes important, because we're starting to involve the business. So some of those problems that we saw in the example data, like the addresses, like the city of Odessa, like the names and of companies, we saw those problems. And one of the first problem that Roman is going to have, and I'm glad I can take this away from him, is that he actually has to discover those problems first. And as we were talking before the webinar, some of the approaches that he was going to take was taking each column of data in the file, grouping those values, and then ordering them. And that would help him find out values that are similar to each other, but he would need to spend a lot of time encoding that. And also, in some cases, he might not be able to actually make the decision himself. He needs someone from the business. So there are much nicer ways to do this. What I've done is, out of those 2.7 or 2.3 million records that were loaded in from that file, I've just loaded up a very small snapshot of that data from CluedIn, just to show you how, as a data steward, you would spend your time in CluedIn. Let's take something like the city, right? So we've brought this data in from a public source, and instead of me having to go off and ask Roman to discover what the problems are, In CluedIn, we can run a similar type of technique. We can group the values. So I'm going to run what's called a text facet. And over on the left-hand side, we can see that CluedIn has broken down these values into groups. So for example, there are 2 cities that have the value of Chandler. That's great. Now, still, I have this problem of, okay, well, how do I find where the problems are? Do I have to manually go through this in order? Of course, there are 1,145 choices. That would take me way too long, especially considering I've got 2.3 million records to eventually go through. This is where the platform becomes super valuable. Instead, I'm going to ask CluedIn to go off and start to make suggestions for me. So I'm going to click this cluster button. And what this does is it uses different techniques to try and find if there are values that are the same. And as we go through some of these different techniques, we can start to see that as a business user, I'm quite comfortable with making the recommendation that here are 2 cities, and they are essentially being detected as the same city, but just represented differently. So what I can do is I can say, okay, well, CluedIn is making a suggestion that this should be St. Louis. And this suggestion is essentially based off the fact that most of the values are alluding to that. So I'm quite happy with that suggestion from the platform. So I'm going to say, yes, I think that's a good choice to turn St. Louis into St. Louis. And I'm going to merge that and recluster. So I fixed that particular problem. But as I go through the different techniques, they all pick up on different variations and permutations of the same problem. In this case, we've got Lagrange or Fallon, just represented differently. So as a business user, I can start to go through and say, yes, I think that's what we should fix. Yes, that's what I think we should fix. I'd like to go off and make that change, and I'm happy with it as well. As you make these changes in the platform, it's building up essentially a list of changes. We can always undo what we want. Think of this as a safe space for your data, where your data stewards and your business analysts can quite happily play around with what they're seeing in the data itself. Now, as we go on to some of these other fields, things like what year they graduated in, last names, maybe what medical school they went to, these will also start to bring up other types of problems as well. So for example, we can see that here's Palmer College Chiropractic Davenport, and we can see some examples where, no, I'm fine as a business user not to merge those. So you actually have a choice, and we can use this tolerance level to move the tolerance up and down and be more picky or less picky essentially. But as we go through some of these other techniques, it's very easy to see that University of Washington School of Medicine and Washington University, those are semantically the same value. So I can tell the system to go off and fix those problems. So really, this is quite an iterative approach. And notice I haven't had to do any of the discovery. Those suggestions have been made on my behalf. And now it's just about a business user actually deciding what fix to make. Now, of course, there's 2.3 million records. And so I won't spend time fixing all the issues. But before the webinar, Roman and I actually spent some time in going through and fixing all the problems. And the first gigabyte file that we got through from data.gov on this took us about 42 minutes to clean all of the problems. Now, the important thing is that we only want to spend time fixing these problems once. So let's close this down. Now, what happens is that when I'm happy with my changes, I can click this commit button. And what that will do is not only process the data in CluedIn, but if we head over to the rules part of CluedIn, what it will do is it will start to create all these business rules off the back of the decisions that I've made in that cleaning application. Now, the beauty of this, if I just click on one of these like Clear Lake, is that this is 100% explainable to the business. In this case, we're saying that if a doctor's city is equal to Clear Lake with a space in between it, then the action is actually to set the value to Clearlake, right? So that's the action that we're going to take. This is explainable with a full audit log. No need to, have to go back to engineering to ask what code they wrote to make these transformations. This lineage and this audit trail of data changes is all done for me. If we go just take a look at another one like let's just take this Cape May. This is, once again, where the city comes through as Cape May Courthouse. Your job is to turn it automatically into Cape May Courthouse. So fully explainable, full lineage, full audit trail, but somehow we need to get this over to Roman, and so he can run this logic within his local code. So that's where the two lines of code that I just shared with Roman before become really important. So Roman, I'm going to head back. Let's head back to the code now that you've added those two lines in, and let's take a look and talk through how this has essentially transformed the way that you run your Databricks jobs now.
Thank you, Tim. I already run the code, and as the first line gets me access to CluedIn API, and the second can bring me the rules that you just created. Like this, so I almost immediately get the list of the rules.
There's that Cape May. Yeah, that's the Cape May one that we just saw before. Great.
Exactly. And also the Clearlake also here, and how we're supposed to change it. So when I wrote this a small snippet of code that actually applies all the rules that I grabbed from CluedIn to my data set. And what I like in this code is that I don't have to change it later on if you will add more rules in CluedIn, because I can just pull the new rules and update my data set. And running this code took me about less than a minute, 48 seconds in the current case. Excellent. To process 2,300,000 of records. And what I can see as a result is if I check for any Clearlake, and I can see that there is 0, but I'm quite sure what we've been here. And if I check for Clearlake, I can see what were 200. Yeah, so the values were replaced. So you actually allowed me to spend my time on more creative tasks than just replacing dummy values from the files on a daily basis.
This is fantastic, Roman. I'm sure we're all happy about that you can go off and start working and not be bogged down on the same monotonous, tedious task every day, just fixing small little spelling mistakes and white space and, tokenization issues as well. So I think it's important to call out a couple of things here. First of all, we could not have done this without Databricks and Spark, right? Spark brings us that ability to process this amount of records with this transformation in under a minute. And it's worth calling out that I believe, Roman, this is the smallest instance possible on Azure Databricks as well, right?
Exactly. That's just default cluster. You can scale it.
Excellent. So really now, as we get that 1 GB file through our delivered to us every day, really then it's just a problem of how, we only need to now fix the new permutations of problems that we haven't seen before. But as you said, Roman, now that my team's spending time from a data steward's perspective in fixing the problems, your code is already set up to just get the new rules whenever they're created. So this is now a live operational pipe. And I think what's most important here is that is the fact that we could still keep the performance that Databricks gives us. So I guess one of the things from an engineering perspective is that really Databricks is built on the premise and Spark is built on the premise of things run in memory, right? That we're not calling out to public services while the job is running. And if we did that, it'd probably turn out that this would take a couple of hours to run, as it needs to reach out to an external service or CluedIn every time we've got a new record through. So the beauty of this approach is actually before Roman runs the job, he fetches all the rules in bulk from CluedIn, and this could be hundreds, if not thousands of rules. And that could take a couple of seconds to go and fetch that, because it has to go over the wire, it has to get all that JSON back, and has to convert it locally into something that essentially evaluates to code. So we can still maintain that everything runs in memory and get that use out of Databricks as well. Thanks so much, Roman, and thanks for showing us that. I think we've got a good way forward. Excellent. So I'll just take the presenting back, and let's head back into the slides. So for those who kind of want to see what's happening underneath, essentially what's happening is that CluedIn is translating that business-friendly business rule into an IT-friendly representation of that. So just in one simple example, if we have a rule that where the city equals Copenhagen with a K, we might want to normalize all that into Copenhagen with a C. So the logic on the left is essentially translated into some type of code logic that probably looks a little bit like on the right. Now, of course, the beautiful part is this is all done for you, right? So this translation is done for you. And the good thing is that we have multiple support for different languages. So you obviously just saw Roman there use Python as the way to be able to transform that code. But we also do support this same technique in Java, in .NET, in PHP, Rails, Go, and JavaScript, with a roadmap to be able to support more in the future as well. But in regards to Databricks and Spark, you've definitely got support here with either the Java and the Python libraries. And of course, you've also got things like Spark.NET, the native .NET client to run .NET code against Spark. But the addition thing is this doesn't necessarily always just have to run on Spark. This is just being able to transpose that logic in the business rules into any code. So this could be just run in normal web applications as well. So super powerful way to bridge business and IT. And of course, at CluedIn, we're only focusing on the rules engine for now and how that helps Databricks. Of course, get in touch if you'd like to see how some of the other data governance, data lineage, and data quality pieces could also help you as well. So now we're going to spend a little bit of time on the business outcome itself. Now, if anyone has any questions in the meantime, please use the chat feature and the questions feature that's available in the GoToWebinar meeting application that you've got, and we'll try to answer those at the end of the webinar. Also, do feel free to get in contact if you want to go into a little bit more detail, and I'll talk a little bit about how you can get in contact in a moment. So really when it comes to the business outcomes and benefits of CluedIn and Databricks working together to bridge business and IT, I think hopefully what we've been able to show here is that as the number of business rules that my team builds up over time, that means that essentially we can get to the point where we've seen the 99 percentile of problems in the past, and we've got an automated business rule to make a decision on that. So really the amount of time that your teams, whether that's engineering or business, will be spending in fixing data quality issues like you saw, the amount of time will just get less and less and less over time to the point where you can get it close to automation and only be handling these small permutations you haven't seen before. I think one of the other big benefits of combining these technologies is that we're taking IT and engineering as the main dependency in this process. Now, IT will always play a role in these data stacks. And as you can see, Roman still is needed to set up the pipeline. He's still needed to maybe solve some of the data engineering fixes that is fantastic to do in engineering. For example, one of those columns was storing dates in different formats. That's something that Roman can probably tackle the majority of problems in his Python code. We should still be doing that. It's these permutations of problems such as the 11th of December and the 12th of November, where if we don't know what time zone that date was created in, we have to surface that to someone to be able to make a decision on, is that the 11th of December or is it the 12th of November? Because both of those essentially could be represented in different date formats. So there are still even engineering parts that will always need to evolve the business. And we think this is a great way to bridge those. So the fact that we have now established an operational data quality pipeline that's driven and implemented by the business, all we needed to make sure we had that bridging code over to the Azure Databricks jobs. That's what makes this possible. Now, some of the other pieces that make this possible is some of the other, I guess, unique selling points of CluedIn itself. Now, CluedIn is a native Azure solution built for the cloud, designed for the cloud, which means it's also ready to take advantage of the economic scale of the cloud as well. Now, some of the other parts that make this engine possible and also make it as a leader in solving data quality is CluedIn's unique use of a graph database for modeling its data. CluedIn has essentially a unique selling point called the zero modeling, right? Zero modeling really refers to the fact that we don't need to have a perfect view and model of our data up front before we start using the data. In the example we've just seen before, where we brought in the doctor data, what you'll typically be used to in data projects is the first thing we need to do is come up with a model and a storage for what a doctor looks like and what metadata and properties that doctor has on it. And often this leads to also very time-consuming upfront projects where it's 6 months before we have data out in the business and proving any value. And CluedIn is also a huge accelerator for your projects when it comes to building semantic models and having less time in doing that upfront data modeling. This is the thing that always takes that first 3 or 4 months of a project. And with CluedIn, you're up and running with data and pushing it out to the business sooner than later. So what we've also seen as some of the business outcomes and benefits here is that speed to insight. Is that if I can basically shortcut Roman having to fix all those problems himself and his team, you can probably see that we can start using that data sooner. I think the other thing with the speed to market and how you can get data out into the business sooner than later, if we are actually building up this huge repository of business rules and automated transformations, the possibility of new data entering the system and already having a fix just grows and grows over time, the more time you spend with CluedIn and your data steward spending cleaning that data. I think the other big value that we can all see here is that sustainability, in that we're not always having to involve Roman or IT every time we see a new problem. Every time we see a new permutation of a city that we need to fix, we don't have to join a queue for Roman's team, wait for him to find the time for us, and then only realize later that we've got a whole new list of problems that we've detected. And this, you can just see how this really won't scale in regards to the fact that we get this data on a daily basis. Just the sheer amount and the fact that we can remove IT from huge parts of that process is immensely valuable. So on behalf of Roman and the rest of the CluedIn team, I thank everyone for joining this webinar. If you'd like to get in touch, feel free to sign up for a personalized demo from our website. You can also download some material on the specific content directly from the collateral part of our website. We have white papers, we have video demonstrations of how this works. And of course, this webinar will be recorded and the slides will be sent out to everyone who attended. So for those of you who have joined us, thank you for spending the time with us, and we hope to talk to you all soon. Have a lovely day.